Hello everyone. Today we're gonna take a look at how to build a logistic regression model using TensorFlow.js and use it to predict whether or not a patient has diabetes. To do that, let's have a look at what logistic regression is and how we can actually use it. So the first thing to know about the logistic regression is that it allows you to answer binary questions, and more importantly, it offers probability for each answer that is giving you. So for example, if a person has diabetes, if you ask it if a person has diabetes, it will tell you yes with 80% probability and no with 20% probabilities. Okay, so some of the questions that logistic regression can answer are things like, is this email a spam? Should I ask my boss for a higher salary? Does this patient have diabetes? Etc. Okay, so to actually understand what the logistic regression is, we have to start with the linear model. And the linear model is really simple. We can define it as using this equation right here, where x is the data that we have for our training for our model, and b1 and b0 are parameters that we're going to learn during the training of our model. Here, b1 controls the slope of the linear model. That means like this angle right here. And b0 controls the intercept, or the point at which this line intercepts with the x-axis, so it controls the vertical position of this line along the y-axis. Okay, so this is the linear model, and if we take a look at the separation of the outcome, or whether or not a person has diabetes, based on the glucose test, you must know that this data is actually fake data. It's not coming directly from our dataset. It's a little bit random, and it is shown here for the purposes of this video. So this is not actually data from our dataset. And as you can see, the linear model can be used to provide an inference or an answer to the question, is this patient having diabetes? But as you can see, this line doesn't separate very well the two groups of patients. Okay, so this is where we need something else, and this something else, at least for now, is going to be a logistic regression model. To arrive at the logistic regression model, we're going to use the linear model and apply a softmax function to it, which is defined as such right here. And when we input the linear model equation right here, we arrive at the softmax regression model. The softmax regression model is a generalization of the logistic regression model, and it allows us to do classification with more than two classes. So we can answer questions like, what is this type of flower, for example, and you have three types of possible flowers: roses, violets, and something else. Okay, so the softmax regression has the following equation, and the curve that is represented right here is actually a simple fitted model using softmax regression. Again, the parameters which we are going to learn in here are b1 and b2 and b0. I'm sorry, and b1 defines the steepness, or you can think of these angles right here, how steep this curve is, and b0 moves the curve to the left or to the right along the x-axis. Okay, so we want to build some model that creates this curve and predicts whether or not a patient has diabetes. And to do that, we're going to use TensorFlow.js. Okay, so I have already started the project that we've left off with last time, and here is our code, at least for now. Okay, so I'm going to remove those two lines for now, and we are left with the datasets that we had. Okay, so the first thing that I'm going to do is build the model, and to do that, I'm going to create a new function that we're gonna call, let me get this bigger, that we're going to call train logistic regression. And it's going to be an async function. It's going to take the number of features that we have, the training dataset and the validation dataset. Okay, so in here I'm going to define our model, apply all the necessary steps that are required by TensorFlow.js for it, and train it using the data and return the already trained model from here. Okay, so how do we create a model using TensorFlow.js? If we go to the API in TensorFlow.js, you're gonna see a section called models, and this section is showing that there are actually two ways to create a model, one using tf.sequential and one using tf.model. And as you can see, this is part of the layers, TensorFlow.js layers API, which is a high level abstraction that allows you to build rather simple or well-defined models. You can use the TFJS core API to build somewhat more complex models if that's what you want, but for the purposes of our tutorials, we're most probably going to use only the sequential or model API to build models. Okay, so there are two ways to create a model, and in here you can see that there is sequential and model. Okay, so the sequential is allowing you to add layers on top of each other, and in this way you can build your models just like it's shown right here. Okay, so this is a really easy way to build your models, and here are some other examples if you want to see those. And there is a model, tf.model function, that allows you to build like rather more complex or models with more flexibility. At least for now we're going to use sequential, and if we need to use the model API, we're going to take a look at it again. Okay, so for now I'm going to open Visual Studio Code and create a model using sequential. Okay, so now that we have a model, we need to add parameters for it. And again, if I go back to the logistic regression example that we had over here, our model is going to have two parameters, b0 and b1. Okay, so how do we do that in TensorFlow.js? We're going to use again the layers API and add a dense layer with two parameters. You don't know, you don't have to know what dense means for now, but the important part of this is that we need to create a dense layer. Okay, so the layers API has the dense function, and in here I'm going to specify a couple of things. The first thing is the units property, and I'm going to specify that as 2 because we have one hot encoded vector, if you remember for the last time. So if the response for a patient is that it has diabetes, the response of our model should be 0, 1, a vector of 0 and 1. And if the patient is healthy, we're going to receive a response, a result of 1 and 0. Okay. So the next thing that I'm going to specify is the activation function. And in here, I'm going to put in the softmax function. So TensorFlow.js will allows us to apply a softmax function to the result of our layer. And for the purposes of the logistic regression model, we are going to use again the softmax function. So we're building a softmax regression model in here. And the next thing that it is required for us is to specify the input shape. And the input shape is the number of features that we're going to use. So as you can see, we have the feature count parameter in our function, so we're going to put in just that. Okay, so now that we have created our model and added a layer to it using the TF.js layers API, we are going to have to do another step, and this step is to compile the model. So what does compiling the model means? If you go to the API, let me check and see. Okay, here is the compile, and the documentation says that it configures and prepares the model for training and evaluation. This is like a pretty, in my opinion, this is like bad design, because you have to remember to compile actually every time your model, and you might forget to do that. It's not like intuitive. The intuitive thing is to build it and train it. This compile step is rather, at least in my opinion, a bit strange, but the TensorFlow.js API requires for us to compile our models. And as you can see, the compile is actually, the required parameters for the compilation of our model are the optimizer and a specification of the loss function. Okay, so the optimizer is going to actually train our model and feed it and learn the parameters that we want to learn, the B1 and B0 parameters. And the loss function that we are going to use is going to be, let me have a look at it. Okay, and the loss function that we're going to use for our regression model is going to be cross-entropy loss, which allows us to evaluate how well a classification model is performing. A classification model is a model that returns some classification result based on the number of classes that it has. In our case, the number of classes are 2. We have a class for patients that have diabetes and a class for patients that are healthy. If you had more classes, this one will work as well. So it is pretty generic, and you can use it in your classification tasks. Okay, so let's compile our model. I'm going to call model.compile and specify the optimizer. And for optimizer, we're going to use Atom. This is just one of the optimizers that we have, and that is rather largely used in practice, but some tasks might not work very well with the Atom optimizer. The optimization part of your models is really interesting because there are no general good solutions for every problem, and you might want to experiment a bit with the optimizers and their parameters, etc., etc. So the first thing that is the only thing that is actually required by this optimizer is the learning rate, and I'm going to specify a learning rate of 0.001. Okay, so the learning rate controls how fast the algorithm or the optimizer is taking into account new data, something new that it's learned, and actually forgets the old stuff that it already knows. That's it for now. We're gonna take a look at the optimizers in depth in another part of this series, but for now this should let you just do the logistic regression model. And for a loss function, we've already discussed the cross-entropy function, but there is a special case of it. It's called binary cross-entropy, and we're going to use that because we have just two classes in our case. And the last parameter are the metrics that we want TensorFlow.js to record during training, and we want to have a look at the accuracy of our model. Okay, so our model is now built and then compiled. Let me just call this function and await for it result to at first we're going to use just a single feature, and that one is going to be glucose. And I'm going to pass in the training dataset and the validation dataset. And let's see if all of this is running smoothly. Okay, so we don't have any errors, and you can actually return the model from here. Take it and then ask for the summary of it, I think. Okay, so here is the summary. Of our model, so everything seems to be working fine. Okay, so the next thing that we're going to do is call the fit dataset model, which will use our model that we've already defined. Let me have a look at the model, the method. Okay, trains the model using a dataset object. So we have our dataset that we've prepared using the create datasets function, and now we're going to pass the dataset to the fit dataset method. Okay, so let's do that. Fit dataset, and I'm going to pass in the train dataset. There are a couple of options that we want to specify in here. First is the number of epochs, and the number of epochs, if you remember, is the number of times that the model is going to see all of the training data. So let's start with something simple like 10 epochs. The next thing that I'm going to do is provide validation data, and here I'm going to provide the validation data set. And for now, that's pretty much it. Let's try to run all of this and see what happens. Okay, so our model is done with the training, so that runs pretty fast. And again, we have just a single feature. Okay, so the training, actually you trained your first model right now, but you didn't know what happened at all. So it might be helpful to have a look at the training process in depth and actually see what is happening. To do that, we're going to use another option in here, which is called callbacks. And a callback that we're interested in during training is called onEpochEnd. So after each epoch is complete in the training process, we're going to receive a callback. And the callback is going to be async function. And this method is going to receive the current epoch in the walks or in the walks of the training, or the information of the training. So the first thing that I'm going to do in here is actually collect the walks. Then I'm going to create two containers, and those two containers are going to be used for the visualization of our accuracy and our was function during training. To do that, I'm going to go to the index.html file and create two more divs. The first one is going to be called was container, and the second one is going to be accuracy container. Okay, so the was container, we're going to use the DOM API to get the element by ID. And the accuracy container. Okay. So all of the training walks will be stored in our array called train walks. And when an epoch is completed, we're going to append the current walks to all training walks that we've already obtained, and then we're going to use the tf_vis library. And to do that, I'm going to actually check if it is already installed, and it is not, so we'll have to install it for this project. Okay, let's go and see the installation step. Okay, here it is. I'm going to stop the server, add the tf_vis library, then run the server again. Go to Visual Studio Code and import the library as tf_vis from TensorFlow.js, and when we go to the onEpochEnd callback, I'm going to show history, which shows the training history of our model, pass in the container, the div, and in here I'm going to put in the training walks, and as a last parameter I'm going to specify that I want the was values and the validation was values in here. So if we run all of this, train walks, oh, I'm sorry, it's not append, it's push. I'm confused with the Python API, and this thing is taking a bit too long to build. Okay, we'll wait for it. And during this time I'm going to also visualize the accuracy. Okay, so this thing said that we're out of memory, which is strange. but let's try it again, and hopefully it should work this time. Okay, so everything is working now. I had to increase the amount of RAM that is given to the Node.js process. So after that is done, we can have a look at the training. And as you can see, during training, we have two nice charts that show us the loss and the accuracy during training on the training and the validation sets. So something that I forgot to do is actually await for the training to complete. And now that we have our model running, I'm going to increase the number of epochs to 100. Save that and go to the training page. So after the page refreshes, you can have a look at real time at the training process. And the thing that you have to look for in here is the accuracy, which is on the top, and we are really interested in the accuracy of the orange line or the validation set. And if you recall correctly, you might know that if we predict something like 65% of the time that the patient is healthy, our model is going to be just as good as a dummy model. So for now, it doesn't look like the accuracy is increasing, and it doesn't look like the validation is decreasing also. So one thing we can try to do right now in a situation like this is just provide more data to our model. So let's try that. And to do that, I'm going to just pass in more columns in here from our data. Okay, to do that, let me just choose some. I'm going to keep the glucose one. I'm going to enter the age, because if you remember, during our analysis, we had a look at the age, and the age is separating somewhat the healthy and the diabetic patients. Another thing that we might consider are the insulin levels, so I'm going to input those as well. So age, insulin, and I'm going to put in blood pressure as well. Okay, so now that we have this model, I'm going to have to, let me just extract that as a constant called features, use that in here, and then just provide the number of features as first parameter for our training method. Okay, and if we go to the logistic regression training page, we have to observe the new training process with the new data. Okay, let's check if there is an error, and there is. Tensor must have a shape comprised of positive integers but got shaped too. Okay, so I've made a mistake somewhere, and it's not, and okay, so that should do it. Okay, so the training begins, and as you can see, the loss function has already started decreasing, which is a good sign. compared to the was function that we had previously, it was staying right about 6 or something like that. And the accuracy has also increased, but not as much as you might have expected. So let's just wait and see what happens after the training is complete. Okay, so we're at epoch around 80 right now, and you can see that the was is actually not decreasing anymore. And this might be related to a couple of reasons. Our warning rate might be too large, or our dataset might not be sufficient for our model to train on it and find even better values for our parameters. And as you can see, the process has finished, and at the last epoch we have an accuracy of 60%, which is pretty low, and on the best ones we had an accuracy of around 78%, which is rather good. Okay, so the thing that I'm going to try to do right now is represent the results in another way using a so-called confusion matrix. And to do that, I'm going to need to change the create datasets function. I'm going to need from that function to return a set that we are going to create to use for the confusion matrix. And to do that I'm going to create two tensors. One from the x's and one from the y's. This data will be identical to the one that we used for the validation dataset. So now that we are returning those two values as well, I'm going to go to the bottom of the screen where we call the create datasets function, and I'm going to get those values from the array using the array destruction methods. Okay, so now that we have those, after the training is complete, I'm going to ask our model to make predictions, then take the real values for those predictions, use TFGS vis to create a confusion matrix, and we will see in a bit what a confusion matrix is, and try to evaluate how well our model is actually doing. Okay, so let's take the predictions from our model, and we're going to do that using the model.predict method. From it, I'm going to ask it to predict the results for the xtest variable, and I'm going to take not the probability that's returned from this model, but I'm going to take the value that is with the highest, the value that is the highest. So if you have a result that is, yes, this patient is 55% diabetes, has diabetes with 55% certainty, and it's healthy with 45% certainty, this will return 1, because the patient is more likely to be diabetic. And for the labels, I'm going to do the same thing. Again, take the maximum value, since they're one-hot encoded. To create a confusion matrix, I'm going to use TFGS vis, and in here we have the matrix, and in here we have a confusion matrix, and to that I'm going to provide the labels and the predictions. To visualize the matrix, I'm going to need a container, which is going to be a DOM element, a div, which we are going to call confusion-matrix. and I'm going to come in here, create a div. Okay, create the div, and then we're going to use the render method, the render package from the TFJS vis, and pass into the confusion matrix method the container and a couple of options, the values, the confusion matrix, and the labels, which are going to be healthy and BDIC, and I'm going to wrap that into an array. So that should pretty much does the job for us. And if we wait for another training of our model, which as you can see is rather slow, we're going to have a look at what the confusion matrix really is and how well our classifier is doing. This time around you can see that the optimizer is actually not finding good values, and the loss is not decreasing. So for now I'm going to just refresh and hope for a better initialization of the optimizer. So why this happens, as you might already know, the training process is related with a lot of random values in the parameters and in the optimizer, etc, etc. And sometimes if this random value is not good enough to initialize the training process, actually your optimizer might not perform well. So as you can see, this time around it's even worse. I'm going to try it once again. And this time around it looks like, yes, the optimizer have found better values for our parameters. The loss has decreased, at least until this point, and it still hasn't decreased to the point that we've been in the first run, but I'll wait for this training to complete and see whether or not we're going to find better values. But even if we don't, I'm going to just wait for the results and show you what the confusion matrix looks like. Okay, so here is the confusion matrix, and the confusion matrix, let me just, okay, I'll rerun that because the confusion matrix is like too wide for us to watch. I did. And hopefully this time around the optimizer will find better values. But even if it doesn't, I'm going to show you the matrix, and then I'm going to show you how to build a somewhat more complex model that performs better. So as you can see, the training has completed, and the confusion matrix actually shows us that the model is overly predicting that a patient is healthy, and it doesn't get the ones that are actually having diabetes. Okay, so I'm going to quickly show you how to create a somewhat more complex model without explaining, at least for now, what is happening, and see that the model can be more complex, even though you have the same data, you can make better predictions using it. Okay, so let's have a look at this complex model. I'm going to go to the train logistic regression function that we've defined, and I'm going to add another layer to this model. Again, that layer is going to be a dense one, and instead of, I'm sorry, I have a typo, and instead of the 2 units that we already had, I'm going to put in 12. So these will be parameters that our model should learn during the training. I'm going to put in an activation function known as relu, and the input shape in here is going to be removed because we are already using that in here. So this is the more complex model, which just adds another layer, and let's have a look at what we've got after training. Okay, so we have an error. Okay, so that should be fine. Okay, so yeah, the training has begun. I'm going to pause the video and show you the results. So after the training is complete, you can see that the confusion matrix looks much better this time around, and the validation accuracy is not that much better, but the confusion matrix is showing us a rather large improvement compared to the simple model that we've used before. Okay, so we've created a logistic regression model at first, tried it, we saw that it didn't work that well, and after that we've increased the complexity of the model while also increasing the amount of data that our model is looking at, and we've obtained a model that is somewhat good, and it can predict whether or not a patient has diabetes or it is healthy. Okay, so thanks for listening and looking at my video. Next time around, I'm going to show you how to build a simple neural network in TensorFlow.js, and please share and subscribe. Bye bye.